In this section, you will learn how to prove triangles congruent by SAS and HL. When you use SAS, the thing to remember is that when you have two sides and one angle, that angle must be included between the two sides. So look at the drawing over here on the right. Angle A is included between the two highlighted sides, whereas angle B is not included because angle B has one side that's highlighted, the other one is not. So make sure that when you're trying to use SAS, the angle is included between the two sides, and you can think of it this way, that your side is like a V and your angle is included in that. So side angle side postulate says if two sides and an included angle are congruent to two sides and included of a second triangle, then the two triangles are congruent. So here you're given that AC, side AC is congruent to side DF, side AB is congruent to side DE, and angle A over here is it's congruent to angle D, and they're both included angles. So therefore you can say that triangle BAC is congruent to triangle EDF. To check this congruency statement, let's see. Check and see, is segment BA congruent to segment ED? BA and ED. Yes, it is. Is segment AC. So that's this one, congruent to segment DF. AC and DF. And finally, according according to the congruency statement, is angle A over here, is it congruent to angle D? Angle A is congruent to angle D, and that is also a check. So BA and ED, I'm looking again, that's got two check marks. Segment AC and segment DF is one check mark, so these two are congruent. Next we move on to the hypotenuse leg theorem, but before we do that, let's just remind ourselves of how to name the sides of a right triangle. In a right triangle, the highlighted side, the hypotenuse, is opposite to the right angle, and it's always the longest side in that triangle. The two sides highlighted in blue are called the legs. They include the right angle. They are the sides of the right angle. We say they are adjacent to the right angle. So in a right triangle, the longest side opposite the right angle is the hypotenuse. The other two sides, including the right angle, are legs. Hypotenuse leg congruence theorem over here. So if you check over here, segment AC, which is a leg, that's the leg, and a leg are congruent. Segment AB and DE, this is the hypotenuse and hypotenuse, and they are congruent. And finally, you really do know that angle C and angle F, they're congruent because all right triangles are congruent. So my congruency statement is triangle BAC is congruent to triangle EDF, and the order matters, so you can check it as we did previously.